Question 7 says we should express 9,360 as a product of its prime factors using the division table. So this is going to be 9,360 divided by 2. 2 into 9 is 4 times remainder 1. This becomes 13. 2 into 13 is 6 times remainder 1. This is 16. 2 into 16 is 8 remainder 0. 2 into 0 is 0. 2 can still divide. 2 into 4 is 2. 2 into 6 is 3. 2 into 8 is 4 and 0. 2 can still divide. 2 into 2 is 1. 2 into 3 is 1 remainder 1. 2 into 14 is 7 and 2 into 0 is 0. 2 can still divide. 2 into 1 it cannot. 2 into 11 is 5 times remainder 1. 2 into 17 is 8 times remainder 1. 2 into 10 is 5. 5 can still divide since 2 cannot. And okay, 3 can divide because the sum of this gives you a multiple of 3. So 3 into 5 is 1 remainder 2. 3 into 28 is 9 times remainder 1. 3 into 15 is 5. Can 3 divide? Yes. 3 into 19 is 6 times remainder 1, and 3 into 15 is 5 times. Can 3 divide? No, 3 cannot. So we take the next prime number, which is 5. 5 into 6 is 1, remainder 1. 5 into 15 is 3 times. 5 cannot divide, and 13 is a prime number. So you divide by 13, and that gives you 1. So that 9,360 can be expressed as 2 times 2 times 2 times 2 times 3 times 3 times 5 times 13, which in index form is written as 2 raised to the power of 1, 2, 3, 4 times 3 squared times 5 times 13. So in index notation, 9,360 can be expressed as a product of its prime factors as 2 raised to the power of 4 times 3 raised to the power of 2 times 5 times 13. Kindly like my videos as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also share the link with your friends and families so that they can also benefit from our daily classes. We shall now take example 8 on prime factors.